Here we're going to talk about factoring a difference of squares. Eventually, once you recognize this pattern, this might be one of your kind of favorite types of factoring. It's the same as our normal what did it look like before it FOILed, but just once you see the pattern to these, it becomes even easier than our normal guess and check ones to figure out what number could work here. Now, at first it looks a little different, or I guess it makes them easier to recognize. They don't have a middle term, and so if we're really thinking about it, how is this the same as the ones we've been doing? It's like your middle term is 0. It's u squared plus no u's minus 25. And so picture in our normal kind of FOIL situation, we know we're going to have two sets of parentheses. We know to get u squared, it's got to be u times u. And so picture how this limits our options here. What numbers multiply to negative 25 but add to 0? Well, think about numbers that add to 0. Like 3 and negative 3, 7 and negative 7, 5 and negative 5. The only way you're going to get something to add to 0 is they have to be the same number, except for one's plus and one's minus. And so that really narrows down your choices. 5 and negative 5 is really quickly the only thing that works, because you know you have to use the same number, only one's plus, one's minus. Now, notice how this looks like I'm foiling when we add conjugates, because if I FOIL this to check, u squared, but then 5u and negative 5u, my inside-outside terms cancel. So that's why there's no middle term. And so these ones end up, once you notice the pattern, kind of easier and faster to factor because you have a limited number of choices. Now say on this one, they put the x squared after to kind of throw you off, but it's still the exact same thing. I could say, okay, what times what gives me x squared? It just happens to be the second term now. It's got to be x and negative x, right? The plus minus, or you positive times a negative gives you negative. And what two numbers multiply to 49? 7 and 7. And then we could just check by FOILing to make sure that it works. So here's our answer. It's factored. But let's check. 7 times 7 is 49. My outside term is 7 times x, so 7x. My inside term is negative x times 7, so negative 7x. My last term is a negative times a positive, so negative x times x is x squared. Notice how these two cancel. So this is what's happening in difference of squares. It has to be the same two numbers. They have to be conjugates. One's plus and one's minus. That's the only way to get your middle term to cancel. So they're the same as our guess and check. They just end up almost being easier guess and check problems.